Now this question is asked in GATE 2013 and it is about this deadlocks combined with the mutexes. This mutex means, you know, right, semaphores. Now without looking at the theory of deadlocks, I'll just try to explain you this. Let's see if you could understand it. If you don't understand it, maybe after finishing the deadlock concept, again you come and visit this question, you'll understand it. So let me try to do it without explaining you what the deadlock is. Let's see, you know, it is just logical, you know, it is not very difficult. I'll just explain the question and then explain the solution. Try to understand it. I feel that it is logical and you can understand it. See this? Now the question is like this. They are saying that there are three processes X, Y and Z, and all these three processes want to access the shared resources, this critical section, and therefore before accessing the critical section they are using three semaphores and they are performing down operations in three semaphores in the following four ways. You please refer to GATE 2013 question. I am just explaining the question. The question is like this. Again, there are three processes. The three processes are X, Y and Z, and there are three semaphores. The three binary semaphores are A, B and C, and these three processes are concurrent in the sense they want to access the critical section, and before accessing the critical section they are performing down operations on A, B and C in some manner. And now they are asking, you know, if this is the order in which down operations is performed by X, Y and Z on A, B and C, then what can you say about the deadlock? Is deadlock possible? Right? So when do you think deadlock is possible? Earlier also we have seen an example. If one process has taken a semaphore, which means if one process has performed a down on a mutex, and if it is waiting for other mutex which has been already taken up by other process, and if the other process waits for this process, right? Okay, I'll just take the example and explain you. See, now how could deadlock be possible is, whenever such a question is given, I suggest you follow these methods. One thing is trial and error. You have to find out all possible sequences and you have to explore it for yourself, and many times it is simply logical that you can find it out by looking at it. If you don't find it, the method is generally this. Whenever they are performing down operations on many semaphores, try to perform one down operation on each semaphore by each process and preempt it, which means if it is possible to allocate one mutex to each process, give it away and then see what happens. If it is not possible to give one mutex to each process, then give two mutexes to each process and then see what happens, like that. Then you can finally find out that some sequences are going to lead to deadlock. So purely you had to use your intuition and trial and error. So watch this one. Now let us explore the option number A. In option A, say X has executed the first down, which means P on A, which means X has taken the semaphore A and then got preempted, and Y has executed P on B, which means Y has taken the semaphore, the mutex B, and got preempted, and then Z has executed P of C, right, which means Z has taken the mutex C, and after these three lines all of them got preempted. And now let's assume what happens next. Let's see what happens next. X comes for execution and it will ask for P of B, but then B is already taken by Y, isn't it? So, and one more thing, all A, B and C are given that they have been initialized to 1, which means only one process can perform the down operation successfully. So already one process has performed down operation successfully, which is Y. Therefore at this point X will get blocked in the list of semaphore B, right? And now if Y comes for execution, then what happens? Y wants the C, but then C has already been taken by Z, right? Therefore it will get blocked and it will sit in the list of waiting list of C semaphore. And then if Z comes, then it will try for D. What happens? It will get blocked. Why? Because D has already been taken by whom? Oh, D is not taken by anyone. Okay, as of now D is not taken by anyone. Fine. So it will successfully pass this line and then it will go to the next line, which is P of A, isn't it? This line is over, now this line, and then now this line. Now whenever it tries to execute P of A, then what happens is this A has already been taken by X, therefore here it gets blocked. Got it? Now all the three processes got blocked. In fact, if you try to see what is the relationship, who is waiting for whom, you can easily find out that there is a cycle. So whenever there is a cycle, whenever there is a set of processes which are waiting for each other in a cycle or in a loop, right, you can say that it is a deadlock. Again, in deadlock concept, I'll make it clear if you didn't understand here. I think here it is very clear that x got blocked, y got blocked, z got blocked, right? And x is waiting for semaphore B, y is waiting for semaphore C, and z is waiting for semaphore A. But then x is, already x has taken semaphore A like this. Okay, I'll just take the diagram and explain you. See this. Now there are three processes, x, y, and z. Now x has already taken semaphore A, which means x has the control over semaphore A. It has performed it down successfully, and only it could release the semaphore A by performing up. And y has taken semaphore B, and z has taken semaphore C. This is what has happened. And now x is waiting for semaphore B, which means x is waiting for this, right? And y is waiting for semaphore C, which means y is waiting for this. And z is waiting for semaphore A. Z is waiting for this. So if you watch it, x is waiting for y, and y is waiting for z, and z is waiting for x, isn't it? So if you pull out these resources nothing but semaphores, you can see that clearly x is waiting for something from A to, see this, x is waiting for y to finish and release its resource, and y is waiting for z to finish and release its resource before it could finish, and z is waiting for x to finish, right? And everyone is waiting for each other, and therefore they will never get finished. So if you watch it, the loop will be like this, the cycle will be like this. X is waiting for y to finish, y is waiting for z to finish, and z is waiting for x to finish, right? So that is how there is a cycle here, and therefore it is a deadlock. Understood this? Right? So again we shall explore this in the concept of deadlock, but for now it is very simple and you could understand it, I feel, right? So everyone will be waiting for each other. See, if you try to schedule x, you cannot schedule x because it is waiting for y. You cannot schedule y because it is waiting for z. You cannot schedule z because it is waiting for x, right? So nothing will get executed. Everything will get blocked. So all the processes are getting blocked, and they are waiting for each other. So nothing is going to run. So it is a deadlock. Fine. So definitely this option A is having deadlock, right? And now let's explore option B. So actually option B is the answer. I checked it out. So instead of exploring option B, let's explore option C and option D. See, whenever you are not able to find out any deadlock sequence for an option, hold it for some time, go to the other options, and in case if you find the other options to be containing deadlock, you can declare that the remaining option is the one which is not containing deadlock. Okay, let's go for C and explore. See this. Again I told you, try to give them one each and then try to see what happens. Okay, see this. The question is same. There are three processes x, y, and z, and there are four semaphores A, B, C, and D, and all of them are initialized to 1. Then what happens if you follow this execution sequence? Now let's see this option C. Try to give each semaphore, each process one semaphore, and then preempt it and see what happens, right? Now I'm giving P of B, X is executing the first line, which means it got preempted by taking the down operation on B. It got preempted, not blocked, right? So it is successful after this line, but then it got preempted. And now Y got the control over C. It got successfully, successful down operation. It just got preempted. And then Z got P on A, which means it is successful, right? So all these three are as of now successful but got preempted. They didn't get blocked. And now after this again X got a chance and it is performing P on B, P on A. Then what happens is already A has been taken by Z, and again X is trying to take A, which is not possible here, right? Therefore it is going to get blocked. The reason is it is a mutex, right? Its value is initialized to 1. Already one process has performed a down, and it didn't perform up yet. So now it is trying to perform a down. So it is definitely going to get blocked. See, whatever sequence I am showing, they are one of the possible sequences. I am just trying to explore how there could be a possibility of deadlock. It doesn't mean that there will always be a deadlock, but then there is a possibility. That is what I am trying to explore here. Now, Y. Watch it. Now y, next line is p of b, right? Y is waiting for, performing a down on b, but then already x has performed a down on b, therefore it will get blocked, waiting for the semaphore b in the queue of b. And then z will perform p on c, therefore it get blocked here, right? The reason is, already y has performed p of c, and now we are again trying to perform p on a mutex, therefore x, y and z, all of them are going to get blocked, right? Waiting for what? If you want to watch it, see this: x has taken b, and y has taken here c, and z has taken here a, right? And now x is waiting for a, which means x is waiting for a here, right? And y is waiting for b, which means y is waiting for b here, and then z is waiting for c, so z is waiting for c. So now watch it. In this case, x is actually waiting for z to finish and perform a up, and z is waiting for y to finish and perform a up, and y is waiting for x to finish and perform a up, right? Therefore again there is a cycle which is going to be a deadlock. All the set of block process, all these processes are blocked. A set of block process are waiting for some events from the other block process so that they will get unblocked, and therefore they are never going to get unblocked, isn't it? Because of that cycle kind of it, right? So even this one is going to lead to deadlock. Option C is going to lead to deadlock, right? Now let's see the option D. Why am I not exploring option B is I have already explored it and I found out that there is no sequence which is leading to deadlock. That is why I am exploring the others. So it is very, it is like proof by contradiction. I mean, what is that? Selection by elimination. In the sense, if others are not the options, then I could declare that C is the option. Otherwise, it is very difficult to see others. Already we have seen A and C. B is the option. So if I could prove that others are having deadlocks, I can say that B is the answer. Otherwise, if I have to prove that B is deadlock free, I might have to take all possible sequences, explore, and then show that B is true. But then take the other options and we can show that they are not the answers, then we can easily say that this is the answer. So in exam, if you are not able to find a deadlock sequence for some time, at least for 1 or 2 minutes, leave it and go to the other options. Maybe that particular option might be the answer, right? So let's explore D. In this case, D, you cannot give one semaphore to each one. The reason is, see this: if you give A to X and then C to Y, you cannot give again C to Z. Therefore, it is not possible that you can give one semaphore to each and then preempt them. In that case, you have to, I am saying that use your intuition and choose 2 semaphores and give them to each. So here what I do is, I'll try to give 2 semaphores to each one, right? Okay, so what I'll do is, I'll just execute Z first. So why only Z? I explored it. You please explore it, you'll understand it. Now I'll execute Z first, and then I'll take P of C, P of D first. So now it means that Z has taken the control over C and D, and then I'll schedule X and I'll give the control P of A, P of B, and Y wants P of C, but then the problem is C is already taken away by Z, therefore it is going to get blocked, right? And what about Z? Next one is, let us say Z. So Z wants P of A, but then P of A is already taken away by X. A is already taken away by X, therefore it gets blocked. And then Y. Y is already over, right? And then Y is yes, X. Now X wants P of C. X wants C, but then C is already taken by Z, therefore it gets blocked. Now all the 3 processes got blocked in such a way that they are depending on each other. If you want to see how they are depending on each other, watch it. Now Z has taken C and D. Both C and D are taken by Z, and X has taken A and B. which means A and B are under the control of X, only X can release them, right? And now Y is actually waiting for C, which means Y is waiting for here, and Z is waiting for A, which means Z is waiting for X, and then X is waiting for C, which means like this, right? So watch it. Now what has happened is Y is waiting for Z, and Z is waiting for X, right? And X is waiting for again Z. Therefore again there is a cycle, right? But then in this cycle only Z and X are there, right? And Y is not there. So what happens to Y is, it is not actually in this cycle, but still it is going to be blocked and it is going to be in the deadlock. The reason is these two are not going to come out of the cycle, therefore this one will also not come out of the cycle, right? So if Y has to come out of the cycle, no, C has to be released, but then the Y is not going to release the C, because C is taken by because Y wants which one? D. So one second, here Y, what does Y want? No, it is not Y, C. So Y wants C, but then it wants Z to release it, but then Z want A, and A is with the X, right? And now X cannot release A because A wants C, and X wants C, and C is with Z. Therefore in this sequence deadlock is again possible. So even in the option D, deadlock is possible. So only option in which deadlock is not possible is B. This is the answer. See, for explaining it I have taken a lot of time, but then if you do it on your own, you can simply find out the sequences very easily. You can solve it in 1 or 2 minutes. Now you might feel that this question is big, but then if you solve it on your own, it will it will be very, very small. Don't worry about the time, it will be sufficient. So go slowly and analyze it this way. Okay.